Hello, and welcome. I'm Mehmet Ali. Are you a researcher struggling to find meaningful patterns in your complex genetic data? Do you want to discover disease biomarkers without needing to write any code? In this video, I'm excited to introduce BioMark, a web-based tool designed to make powerful biomarker analysis accessible to everyone. Let's dive in and see how it works. When you navigate to our website, you'll see this main interface. You have two options to get started. You can upload your own file with the Browse button, or you can use our built-in demo data. For this tutorial, we'll use the demo dataset for Alzheimer's disease to explore all of the tool's features. Let's click that now. In step 2, we can see the information for our demo file. Now, in step 3, we need to select two key columns from our data. First, the column that specifies the status of our samples, like patient or healthy. For our demo data, this is the diagnosis column. Next, we select the column that contains the unique ID for each sample. Once these are selected, step 4 opens up. In step 4, we can see a bar chart showing the distribution of the different patient groups in our dataset. For this analysis, we want to compare the Alzheimer's disease patients against the healthy control group. AD represents Alzheimer's patients, and control represents the healthy individuals. We'll select both AD and control from the list, and then click Analyze. Now for the exciting part. In step 5, we choose our analysis type. BioMark offers a wide array of biomarker analysis methods, ranging from differential analysis to clustering and classification. For our first example, let's select SHAP, a powerful machine learning-based method for understanding feature importance. I'll keep the default parameters for now. In step 6, we can exclude any columns that aren't needed for the analysis. With everything set up, let's click Run Analysis. The analysis can take a few moments. To save time in this video, we'll skip the waiting period and jump straight to the results. Great! The SHAP analysis gave us a list of important biomarkers from a machine learning perspective. Let's take a moment to dive deeper into these results. First, we'll open the main SHAP summary plot for a global overview. By clicking to expand it, we can clearly see not just which biomarkers are most important, but also how they are influential. Now, let's see SHAP force plot. This fascinating view shows a baseline score and then visualizes how each biomarker acts as a force, pushing the final prediction towards the Alzheimer's classification for this specific sample. What if we want to compare this with a traditional statistical method? Let's use the Perform Another Analysis button to quickly run a second test. This time, I'll select ANOVA. We'll keep the same settings and run the analysis. Perfect! Now we also have the results from ANOVA, which ranks biomarkers based on statistical significance. So, now we have two different biomarker lists, one from SHAP and one from ANOVA. How do we decide which ones are the most reliable overall? This is where BioMark's Combine feature becomes incredibly useful. Let's click the Combine Biomarker List button. We'll tell it to combine the results for our AD and control groups. The resulting table shows us a consolidated ranking. It takes the results from both the SHAP and ANOVA analyses we just ran and creates a final, consensus-based list. This helps us focus on the most promising targets for our research with much higher confidence. Finally, with the Generate Analysis Report button, you can create and download a comprehensive PDF report of all your work. As you can see, the report is structured to provide a complete and transparent record of our entire workflow. It strategically begins with the most critical finding, our final, consolidated biomarker list, which represents the most robust results from our combined approach. Following this summary, the report dives into the detailed evidence supporting these findings. First, we see the SHAP waterfall plots. Each one breaks down a single prediction, showing exactly how the positive and negative contributions from different biomarkers add up to the final score. Next, the force plots provide a different perspective on those same predictions. Next, the SHAP summary plot provides a global overview, showing which biomarkers are most impactful across all samples, while the SHAP heat map visualizes these impacts for the entire patient cohort. The mean SHAP plot then offers a clear bar chart of overall feature importance. Finally, for a complete comparison, the report includes the results from our traditional statistical test, the ANOVA features plot. So, to recap, in just a few minutes, we went from raw data to discovering significant biomarkers, creating a consensus ranking, and generating a full report. To analyze your own data and discover more, I invite you to visit our website. Trying BioMark is free. Thank you for watching.